on some of you and see what you were able to figure out. If you and your group weren't able to figure out, just let me know. So let's start right in the middle with Jeremy. Jeremy, was there any of these you found the values for that you're pretty confident with? The first, okay, what did you get for x here? What does it have to be? Yes. So 2 to the power of negative 1 equals 1 over the power of 2. So yes, x is negative 1 on that one. I might call him someone else, though. Delta, what did you get for b? So you didn't quite get to that one? Okay, what did you get for c? 3? 2? And then you can double check. Is 3 to the power of 2 9? It is. Levi, are there any that you figured out? 0 for D. So he thinks that x equals 0, and then you try that. Is 2 to the power of 0 1? That one is tricky. It's true, but that one is tricky. We really want it to be 0, like so bad we want it to equal 0. So remember, when you have an exponent, it doesn't mean 2 times 0. This doesn't mean 3 times 2. It's a different concept that's fairly new to our brains, so they're still trying to figure out all the ins and outs of it. All right. Alyssa, did you have any other ones that aren't done yet? No, not yet. Macy, did you have any ones that aren't done yet? Okay, let's all look at B then. This needs to be 4 to the power of 2, right? Like we're pretty sure the whole thing, this whole thing needs to be 4 to the power of 2 is 16. So what would the x be to make that true, Sid? Yes. Lots of different ways to kind of try to solve it. Inside, outside, backwards, forwards. Okay, here's the tricky ones. And I don't remember who told me this one. I think it was Levi. It kind of comes from this idea. When we did our exponent unit, and this was a while ago, we learned that x to the power of negative 2, if we want to make the exponent positive, we put it in the denominator and we switch the sign of the exponent. It goes both ways. It goes both ways. So as I'm looking at this here, there's a couple things happening. They don't even have the same bases. What exponent do I need with a 2 so that it will equal 8? Close. Yes. What were you going to say, Logan? Let's just focus on the 8 right now. 2 to the power of what gives me 8? 3 will keep it in the bottom. So if you're correct in a sense. It keeps it in the bottom. If I just want to figure out 2 to the power of what equals 8, I'm just worried about the 8 right now. To get it to go back into the numerator, like Logan was saying, I've got to somehow make this equal to that. So what would it need to be? Yes. X equals negative 1. That one's tricky. And same idea with this one. I'm focusing on the 9 first. I can leave it down there. It helps if these bases are the same, though, don't you find? Now, in order to get it back in the numerator, I'm going to change the sign of that exponent. Now, these are the two things I need to be equal. So x is negative 4. So let's try it. I think x is negative 4. This looks horrible. Does this look like a lie? Yes. So negative 4 plus 2. If you put these in your calculator, they are equivalent. Oh, they don't? It just worked. Did it give you just a decimal? Yeah, which is probably going to be 1/9. Okay. I'm going to start at the beginning now. we'll go through some steps for some that are fairly easy, and then get to the ones with the fractions. So the whole basis of this problem, and I don't think I said it good enough because my last class, they were still confused at the end on some of this. Sarah, will you read that to us? The same positive base b. That's our original focus. So if I have something like this, 2 to the power of x equals 2 to the power of 5. It's saying that these two things are equal. So what does x have to be? 5. And then they just get more difficult from there with different expressions. But the general idea is once your bases, so I'm using these words. This number is my base. This number is called my power. The whole thing is called an exponent. So if I say they have to have the same base, I mean the big number. And if I say set the powers equal to each other, I mean those little exponents up there. Okay, so the if and only if, so it was kind of weird when Sarah was reading that. If and only if, it means it goes back and forth and back and forth. Okay. I know you don't have a huge spot for this. So you can write above the box, around the box, in the box, because the box is not big enough for all of the examples. He's writing notes for math. Okay. Thinking about that theorem that we had Sarah read for us, it says if your bases are equal, which is true for A, it's true for B, it's true for C. Check, our bases are the same. Then I can set the powers equal to each other. So if, check, then. And you can solve. So Porter, for problem A, what will x equal? Yes, 4 plus 1 is 5. Do you know, Porter? 48. Okay, same idea here. If your bases are the same, check. Then you can set your powers equal. There is nothing there. There is. There's an invisible one. It's not a 0, that didn't mean to represent a 0. If there's no showing exponent, it is a 1. That of lead? Where I found this one the other day. This is 0.5. You can just have it though. I hate 0.5. I push too hard. I do. I break it. I have to use bigger lead. All right, Luke, how do I solve this? Yeah, how do I do that? Add 3 and then divide. So I don't know a lot of you well enough to know if you're going to struggle solving algebraically. I hope not, because this is going to be a rough assignment if you do. So make sure you ask me. If you get stuck solving, just make sure you ask. Okay, the third one. Bases are the same. Check. Martha, how do I proceed with these problems then? I'll get you started. So the first thing you need to make sure is true, and if it's not, you need to make it true. You have to have the same base for this to work. On all 3 of these, the bases were the same to begin with. That's not always true. Have I put Paxton to sleep? Are you asleep? Okay. This is kind of boring, I know. Once your bases are the same, you can set your powers, your superpowers, just kidding, equal. So like Martha was saying, my power 3x, I can set equal to my power 2x plus 3. And then I solve it algebraically. Tyson, how do you start to solve this guy? There's 3 correct. That's one of the correct things. It's just, what's the best first thing? I agree. You can move the 3. Subtracting the 2x is going to get you to the answer faster. Okay, just stare at this for a minute. Make sure you can do this because we're moving on to harder ones. So if you're, you are falling asleep. So if these are a struggle for you, just look and see if you can figure out what I've done. Step number 1, are the bases the same? If they are, what do I set equal? Powers. We often call these exponents. I mean, it's not completely untrue, but the whole entire term is called an exponent, which I always thought was weird because we use it incorrectly a lot. Okay, same idea. Step number 1 changes a little bit right now, right? Are the bases the same? No. You've got to find the missing exponent on these ones. I can make the bases the same. I see some of you showing me what it's going to be. So I wish there was a really easy way to do this. All I can tell you is the exponents won't be very big. So on your calculator, you might, well, in your head, you might try 5 squared. Is 5 squared 125? No. If you're not sure, punch it in your calculator. Then try 5 to the power of 3. Does that equal 125? So it took a little bit of work, but are the bases the same? Check. And Lindy, what can I do to solve this now? Well, this one's easy. The powers are going to be equal to one another, which for this one, it was just 1 step. Let's look at the next one. More 1 steps. Yeah, those were kind of fun. Grace, my bases are not the same on this next problem. What should we make them so that they are the same? Yes, so take the bigger one and see if you can make it into the smaller one. So we're finding that mystery number so that it equals 4. Do you guys know what it is? It's 2. Now, make sure you don't ignore that x. He has to come down with it. That's not very friendly. Okay, Jetta, now that I have the same bases, check. How do I solve this problem? The powers will be equal. Okay, I'm not going to solve these ones. I hope you can get the variables on one side. I'm sure there's some of you who struggle with that, but please just let me know during the homework. Okay, the third one on this page. Tristan, what do I do to get started? They do not have the same base. Yeah. Ambrose, is there anything that you think you might want to do to get this one started? We've got a base of 9 and a base of 27. Is there anything you can make it to? So what's 9 squared? It's already too big, right? What do you think? Because that's what we did on the rest of them. It's what? 1.5? Oh, I suppose you could do that. I'm going to show one other way. If that works, you're welcome to do that. I heard you saying it over here. What were you going to do?
I didn't say it. Oh, it was probably you turn them both to 3. Or you could just turn them both to 9s. Yeah. Or you could just like not do the problem. Just turn them both to 9s. So why not?
27.
Yeah. But if you turn it into 9,
This, I think, is the easier way to do it. If you like these other ways, you're welcome to try them out. Okay, CJ. 3 to the power of what is 9? 3 to the power of what is 27? Emery, now that my bases are the same, check, how can I find what the value of x will be? The powers. Set the powers equal to each other, yes. This one's the hardest so far to solve. We have to distribute, we've got to get the variables on one side, blah, blah, blah. I'm hoping that most of us can solve, though. It's getting to the point where you can set up that equation that I'm the most concerned about right now. So any questions on these three? Like, how did you get that number? How did you know to use a 3? All that kind of stuff. Ashlyn, did you get the same answer when you used 1.5? You should. Okay. You should get the same answer. I just haven't tried it. Okay, we have to make the bases the same. Come on. All right. The only ones we haven't practiced are these ones with the fractions. So let's break it down. We need the same base. So at the beginning, I'm going to pretend like this is not in the denominator. I'm just going to ignore that fact. It's okay. It's just okay. I'm not worried about it yet. See if you can figure out 4 to the power of what gives me 64. Don't yell it out. On your calculators, figure out what the exponent would be. Andrew, did you find it? What is it? So you jumped forward a step. Right now it's just going to be 3. Right now it's just going to be 3. But what Andrew was saying, in order to get it into the numerator, now that I have the same bases, Miles, what do? Got the same bases. Set the powers equal. Don't let the fraction confuse you. It was as easy as making the exponent the opposite. Don't let it confuse you. It doesn't need to be the hard part. There's none like that on the homework, so, well, we can do it. Yeah, what do we do on this one, Tate? The weird thing, though, is that the denominator is the smaller value. Yeah, so 2 to the power of what is 4? Now we got to get this in the numerator. There's none like that on the homework. All of them, the denominators are bigger. They're the ones you're fiddling around with. Okay. I don't know if everyone's going to feel comfortable right away getting started on this. So if you find that you are stuck and you're not sure, please make sure to reference your notes, raise your hand, ask a neighbor who you're sitting by currently, and see if maybe they caught on a little bit faster than you did. I don't know.